Okay, we got it. Okay, so today's lecture is covering 1.4, which is all about cost, revenue, profit, supply, and demand. Okay, so this is a business calc course. So this is the section where chapter 1 is kind of relating all of this material about functions and lines and rates of change to the real world through this business kind of lens, okay? So let's get started with the warm-up problem. This is just a problem from one of the previous sections. So it looks like we're supposed to find the equation of this line which passes through these 2 points. Okay, so there's kind of 2 main ways that we could try to tackle this problem. Who wants to tell me one way that we could try to do it?
Find the slope.
Yeah, find the slope. Do you want to use point slope form? Okay, point slope form, that's one way.
Right.
The other way is we could try to calculate the slope and then mix around the equation to get the intercept. Is there anyone here who tried to do it the second way? Okay. For the sake of fairness, I'm going to show you guys the other method for doing a problem like this, which is that method, okay? So point slope we've covered in fairly good detail, so now we're going to try the other way. So the other way is to use slope-intercept form, which remember is y equals mx plus b. And the way we're going to do this is we're going to calculate m, and then we're going to kind of switch around for b, right? Okay, so first of all, m is going to be y2 minus y1 over x2 minus x1. Okay, and then what are we going to do? We're just going to plug in these points here. Okay, so it doesn't really matter which one is which. I'm going to call this one x1, y1, and this one x2, y2. Okay, so I get negative 2 minus 16 divided by negative 2 minus 4. So I'm getting negative 6 on the bottom and a negative 18 on the top. That comes out to positive 3. Okay, so that's m. Okay, so now what we're going to do is we're going to take y equals mx plus b. Well, really, we're going to put in 3x plus b. So we know that we have y equals 3x plus b. And the way we're going to solve for b is just by taking one of these points here. We'll use 4 and 16. And we're going to plug it in and solve for b. Okay, so the x1 is going to go where x is. So we're going to have 16 equals 3 times 4 plus b. So if we subtract 12 from both sides, this is going to tell us that 4 is equal to b. So the equation of our line is going to be y equals 3x plus 4.
What is that? Is that mean? What does that say in there? Beside the 3, 16 equals 3.
Sorry, 3 times 4.
Oh.
Yeah, my handwriting is pretty atrocious, so if you're ever confused, just shout out. Okay, so that's the other way we can do it. It's kind of just a repackaged version of the point slope form. So if you want to just remember the point slope formula and plug in like that, then you can do that, or you can do this method. Okay, both are equally valid. You know, if you were to do one or the other on an exam or something like that, of course I would give you credit for however you want to solve the problem. Okay. So we're going to define cost, revenue, and profit here, and we're also going to define marginal cost, profit, revenue. Okay, so first off, cost is a function C of Q is how we usually write it, where Q is our input, is going to be our quantity of goods, and C is going to represent the cost of that quantity of goods to produce. Okay, relates cost of production, C, to quantity of goods, Q. Okay, so for example, it might take an input of 600 grams of coffee beans, costs $3 to produce, or something like that, okay? Revenue. This is a function R of Q, and it relates price charged R to quantity of goods Q. Okay, so next up we're going to talk about profit, and I'm going to come back to talk about revenue, okay? So profit is going to be, and they do a weird notation in this book, they call it pi of Q. And they say that's going to be equal to R of Q minus C of Q. Okay, so C is representing my cost to produce some goods. R is representing the price that I charge the consumer to buy my goods. And my profit is going to be the difference of these two functions, okay? So it's going to be my revenue minus my costs, okay? So if I spend $10 buying supplies for my lemonade stand, and I make $30 selling lemonade, my cost was 10, my revenue was 30, and my profit is going to be how much money I wound up in my net increase, which would be $20. Okay. Any questions about cost, revenue, profit so far? Okay, now I'm going to give you the confusing definitions, which I really don't know why they use this word, but marginal cost is the rate of change of the cost function. In other words, it's the slope at a given point. If it's a line, it's just going to be constant. Okay, marginal revenue, rate of change of the revenue function. Marginal profit is going to be rate of change of the profit function. Okay, so example, if we have pi of q equals 3q minus 75, then my marginal profit is 3. It's the slope of this line. Yes?
What does it say of the slope in the parentheses?
Yeah, good point. Let me rewrite that better. This is supposed to say slope at a given point.
Thank you.
I have a quick question. Is that under cost? It says C parentheses. Is that A or U for both R and rev and cost? Or is it?
Yes, the inner variable in all of these functions is q.
Okay.
Okay. Any other questions? P of x. The example says pi of q equals 3q minus 75. Any other questions? All right, I'll try to improve my handwriting a little bit. Okay. So, let's try problem 1 together, okay? We're going to use these definitions to try to answer this problem, and then we'll move on and do some other stuff. So, goods R Us has a formula C of Q equals 9,876 plus 0.5 Q to produce Q goods. What is their fixed cost and what is their variable cost? Okay, the fixed cost of this cost function is going to be the part which doesn't change no matter how many goods I produce. In this case, it's going to be my base cost of $9,876. Okay, so our fixed cost is going to be 9,876, and my variable cost is going to be the cost which is associated with each increase in Q. So it's going to be the variable which is attached to Q. So 0, 50 cents. Okay, what might each cost represent physically? Okay, well, this could be, perhaps, price of the factory. And this could be price, not 2 E's, price of materials to produce one toy. Or one good. I guess it's goods R Us, not toys R Us. Okay. Questions about fixed as opposed to variable cost. The variable cost is the one that goes with the variable. The fixed cost is the one that's off on its own. Okay. All right, problem 2 is it's a long problem. We're going to try to go through it together. Okay, Ted wants to start up a lawn care business. It will cost $12,000 to buy all of the lawn equipment that he will need and an average of $4 per job in gas and maintenance. And Ted wants to charge $50 per lawn mowed to his customers. Okay, so we're tasked with finding the revenue function, finding the cost function. We're going to compute marginal revenue and marginal cost. Then we have to find the profit function, marginal profit, and the break-even quantity. Okay, so let's just start with R of Q. Remember, R of Q should be a function which represents how much money I have charged my customers after completing Q jobs. Okay, does anybody want to take a crack at what R is going to be? Hmm? 12,000? 12,000 is going to be our cost. It's going to be our fixed cost. How about revenue? A beat.
200.
200. Where's 200 coming from, may I ask?
$50 per job, and then $4.
I see. So $50 per job, and we have to have a cost of $4 per job. So this 4 is going to be associated with our cost again. Does anybody want to give it another shot, Ryan? 50. We're nearly there. That's okay. Kevin, you got an idea?
50Q.
That's exactly right. 50Q. Okay, so let's unpack that a little bit. The revenue function, remember, it should tell me how much money I've made after I've done a certain number of jobs. So if I input the number of jobs that I do, it should output the amount of money that I make from doing that many jobs. So since Q is the input and Q is the number of jobs, if I do more jobs, I'm going to make more money, which is telling me that this 50 should be attached to our variable, okay? So I should, for each job I do, if Q is 1 or Q is 2, Q is 3, I should make 50, 100, $150 respectively. Are there any further questions about revenue? Yeah, sometimes it's kind of tricky to interpret these word problems, so we're going to do lots of practice. Okay, cost function should be C of Q. So let me erase my little underlines here. Does anybody want to take a crack at the cost function? Ellie? 12,000 plus 4Q. Let me rewrite that Q better. Renee, do you agree?
Yes.
Okay, sweet. So 12,000 plus 4Q, what's the fixed cost? 12,000, that's my startup cost. I have to buy my lawn equipment, right? And my variable cost is the cost that depends on how many lawns I mow. So it's going to be attached to the variable Q. And it's this number $4, which I spend on gas and maintenance. Okay, perfect. Thank you, Ellie. So what else are we supposed to do? Okay, yeah. So that's it. That's A, done. Sweet. So, marginal revenue and marginal cost. Who can tell me the definition of marginal revenue? Do you remember? What does this marginal word mean, Sam?
Rate of change of a revenue function.
Exactly. So what's my marginal revenue gonna be? That's right, just 50. How about my marginal cost? Yep, it's gonna be 4. Okay, so the definition of marginal revenue and marginal cost are the rate of change of the revenue function and the cost function respectively. which means that since these are lines, I know that the rate of change of a line is just the slope of that line. Okay? So my marginal revenue is 50, my marginal cost is 4. Okay. Now we're going to try to write a formula for pi of q. Which, remember, pi of q represents our profit. Okay, kind of weird notation that they use, but we'll roll with it. And let me scroll back up really quickly to the definition of pi of q. We said that the profit function is just going to be our revenue minus our costs. So all I'm going to do to compute pi of q is I'm going to plug in pi of q equals r of q minus c of q. And I'm just going to subtract these two things, where I'm going to take r of q and c of q from part A, and I'm going to plug them in. So this is going to be equal to 50q minus, big set of parentheses here because I want to subtract this whole thing, 12,000 plus 4q. So we can simplify 46q minus 12,000. Okay, so I just take the revenue function and I subtract the cost function. That's how I figure out my profit. Okay, how about marginal profit? What's that going to be? Yeah, I think I heard it. 46. Right? Marginal profit is going to be rate of change of profit function. In other words, 46. Good question. Marginal revenue and marginal cost. Yes, they have. Yeah, they have a physical interpretation. So really, if we were being good calculus students, we would write something like $50 per lawn. $46 per lawn. Thanks for keeping me honest. Okay, let's move on to part E. We want to find the break-even quantity. What does it mean if I break even? If I'm a business person, Sam?
It means when your revenue and your cost cancel out, so you don't have any profit, but you're also not in debt.
Exactly. It's when our profit function is equal to 0. We have made back all of the money that we spent getting started up. Okay? So initially I make this investment of $12,000 to buy all this lawn equipment. And then I have to mow lawns for a while before I've paid off the lawnmower. Then after that point, which we call the break-even point, then I'll be making money. All right? So Sam said it exactly right. We want to find out when is pi of q equal to 0. Okay, pi of q equal to 0 means that our revenue is equal to our costs. Okay? So this just means that 46q minus 12,000 equals to 0. So we move the 12,000 over, divide by 46. We get q equals 12,000 over 46. Which, what is that? Something like 260.8 260.8695 dot dot dot. Okay, so let's interpret this number. This Q equals 260.8695. Who can answer my kind of trick question here? What I'm going to ask is, how many lawns do I have to mow before I break even? Kevin? That's right, 261. Why not 260? Yeah.
Because then you're still at like 11,900 something.
Exactly. What this tells us is we have to mow at least 260.8695 lawns. 260 lawns is not enough. Okay? So I also can't mow just part of a lawn and still get paid for it. I have to mow the whole lawn if I want to get paid. So if I want to go past this point, if I want to hit my break-even quantity, then I have to mow at least 261 lawns. Okay. Let's take a break for a second and ask, are there any questions about problem number 2 having to do with revenue, cost, marginal revenue? Yes?
I'm just kind of confused, like, is it just use pi just because that's what the formula is?
Yes, so in this case, pi is not representing a number. Okay, that's kind of confusing, I know, but you can think of pi of q is kind of like if we were to write p of q. Okay? So pi is just a letter. It's a letter from the Greek alphabet, which happens to represent a number in math, which is why it's confusing that they're using it. But we can also use it as a variable. Okay, so in this case, pi is a variable which represents our profit. Did I answer your question completely? Okay, sweet. Yeah, it's, like I said, I think it's confusing, but we're going to go by the book. If you want to use P, use P. The hero of your own story. Are there any other questions about problem number 2? Okay. I think we're going to come back to 3 if we have time. First, I want to give you the definition of supply and demand. Okay. These are more confusing definitions, okay? So if you don't get this right away, don't worry about it. You'll start to get used to it after a while. Okay, so the supply curve is going to be a curve which relates to units. It's going to relate unit price to quantity of goods which suppliers want to make. I think that that is as concise as I can put it. I'm going to give you the demand definition, and then I'm going to draw some pictures to help us visualize this. The demand curve relates unit price, which, by the way, we represent unit price as P in this case, and quantity of goods as Q, as usual, to quantity of goods which consumers want to buy. Okay. This is a little bit ethereal, I think. So let me draw them. We'll draw the supply. Okay, what's really confusing about the supply and demand curves is that conventionally in financial mathematics, we put quantity of goods on the horizontal axis and price, P, on the vertical axis. However, when you see supply and demand functions written algebraically, they'll be written Q of P, where the quantity of goods that people want to buy depends on the price, or that people want to sell depends on the price, okay? So let me just point out that this is different than usual. Usually our inputs are going to lie on the horizontal axis. In this case, our inputs lie on the vertical axis. And this is just kind of a residual misery left over to us by the people who invented this math back in the day. So if you're confused by that, don't worry about it. It's pretty much the only time I think that this is going to come up. So let's draw what the supply graph might look like. Okay, it relates the unit price to the quantity of goods which suppliers want to make. If I can sell my good for a high price, do I want to make more or less of that good? More. So as price increases, the quantity of goods which suppliers want to make increases. So it's going to look something like this. Okay? As price increases, our Y value is increasing, or our vertical value is increasing, the number of goods which we want to make is also increasing. Okay? So let's do the demand curve. And it's, we'll do Q1 of P for supply, and we'll do Q2 of P for demand. Okay. If the price of an item increases, do I want to buy it more or less? I want to buy less. That's right. So this one's going to look something more like this. If the price is very low, I want to buy a lot. But as the price... what am I doing? Yes. Okay, well... If the price is high, I don't want to buy a lot. As the price decreases, I want to buy more and more. That's how we can consider this curve here. Okay. Like I said, I think these are extremely confusing graphs. So if you want to talk more about it, stick around after class or come to my office hours. We can talk more about it, okay? Before we move on and do a problem involving supply and demand, are there any questions? Yes?
Are we going to talk about price elastic and price inelastic, or do we not have to worry about that?
Good question. Let's talk about it after class. The short answer is, I'm not sure. I haven't looked that far ahead yet in the book. Okay. So, problem number 4. Okay. Anna Marie's love of dogs inspired her to create the perfect dog biscuit and start up a business to share them with the world. Through market research, she found that at a price of $5, she was able to sell 10,100 biscuits, and that every decrease in price by 50 cents would increase the number of biscuits sold by 2,772. Assuming that this relationship between price and quantity is linear, what is the demand function Q in terms of the price P? Okay. So we want to find Q of P equals blank. So what we've seen is that the decrease in price increases the number of biscuits which people out there in the world want to buy. Okay? So the first thing that I'm going to try to figure out is going to be the slope of my function. Okay? Now remember, the slope, m, is equal to the rise over the run. Okay? So what's different about A from previous problems where we found the equation of a line is previously we've usually been given 2 points, and we have to calculate the slope like that. In this problem, we've been given 1 point, right? The point is 5, 10,100, but we don't have a second point. What they do tell us is some kind of roundabout information about the slope in this part right here. What this tells me is that 50-cent decrease corresponds to 2,772 increase in products sold. So what I'm going to try to do is put this into this kind of rise over run setup to calculate my M. Okay. Remember my input here is P, price. Okay. And the run of my rise over run corresponds to change in input. Okay, change in input, which means that I'm going to put the change in input on the bottom. The change in input is 0.5. What's the change in output? 2,772. I'm nearly right. I'm actually incorrect. Can somebody tell me why this is not the right slope? Sam?
Well, you're not increasing by 50 cents, you're decreasing by 50 cents.
Exactly. How can I fix it? Yeah, I'm going to put a negative sign here. Okay, just keeping you guys on your toes. We decreased by 50 cents, which means that my run is negative 0.5, and my rise is positive 2,772. Okay? So this is going to be equal to something like 554. No, 544, excuse me. Okay, so that's my slope.
Could you explain again why the 2,772 is on top?
Yes, I can. So, let me highlight in red. Q is my output, right? My quantity of goods sold, okay? When I talk about the slope of a function, and I say rise over run, when I say rise over run, what I mean is change in output based on a certain change in the input.
So you're basically just looking at the setup of the variables and equations and set it up in the graph, you know, on the graph for the difference.
Yes, yes. What I was describing up here about these being very confusing is just that our input goes on this vertical axis when we do the graph. Everything else algebraically is the same as it was before. Okay, so in our case, Q is the output. So when I want to talk about the rise, I want to talk about the change in output. And the change in quantity is 2,772. The change in price was negative $0.5. So that's why I put negative 0.5 on the run part of my rise over run. Okay, to make some more space here, I'm going to erase this part, but I'm going to leave the slope over here.
Would the slope not be negative since you're running?
Thank you, it is negative. That's absolutely right. And this is m. Okay, so now we have a slope and we have a point. So we're going to use point slope, or we could do the method that we used on the warm-up problem where we rearrange and solve for b. Okay, I'm going to do it the other way, where I rearrange and solve for b. Okay, so I know that q of p should be equal to negative 5, 5, 4, 4, p plus some constant b. Okay, this is the form that I expect this equation to take. And now I'm going to plug in a quantity on the left-hand side and a price on the right-hand side. The ones I'm going to pick are the ones from the problem, 5 and 10,100. So on the left-hand side, I should have 10,100 equals negative 5544 times price is $5. My God, I should have brought a calculator today. Plus B. Okay, so in our case, B is going to be equal to 10,100 plus whatever we get when we multiply 5,544 times 5. Okay. So, finally, why don't I just calculate it? We can give a complete answer to this problem. 5544 times 5. 27,720 plus 10,100. Okay, this is 37,820. Okay, so our final answer here is going to be Q of P equals negative 5544P plus 37,820. Okay. I know that this supply and demand stuff is really kind of counterintuitive. Are there any lingering questions out there? Like I said, it's totally okay if you don't get it at first. It's really weird the way that they do this in the book. Okay, should we move on? We'll move on. Okay, part B. Your answer from part A gives the total number of biscuits that Anna Marie will sell based on the price that she makes each biscuit. Express the total revenue that she will make R in terms of the price of the biscuit P by substituting your answer from part A into the general equation for revenue R equals PQ. Okay, so we have R equals P times Q. We already figured out what Q is in terms of P. So I'm just going to substitute it in. P times, remember Q was equal to negative 5544P plus 37,820. This is equal to negative 5544P squared plus 37,820P. Okay, so when we plug into this formula, we get a quadratic equation. Okay, Your answer from part B should be a quadratic equation with zeros at $0 and $6.82. Okay, so the zeros of this quadratic are at those 2 points. And they want us to explain the meaning of this in terms of the supply and demand. Okay? So, if my revenue function has a 0 based on some given input price, then that means if I set the price of my unit to be that price, then I won't make any revenue. Okay? So, revenue equals 0 implies no money coming in. So, price equals 0. Why does that mean that I'm not making any money? Yeah, Abhi?
I mean, you're not charging.
Yeah, you're giving it away for free. No money. Okay. Slightly more tricky. Why does price equals 6.82 imply no money? Yeah, Ryan?
Because maybe like with the function, like as the like if you increase the price by 50 cents and like it keeps on going, less people buy it, like that's the number that where no one will buy it.
Exactly. If I charge $6.82 per dog biscuit, not a single person will buy one of my items. That's why I won't make any money. Too expensive. Nobody will buy. Okay, let's take a break for a second and ask, does anybody have questions about A, B, and C so far? Okay. Let's take a look at D. All right, we'll finish D quickly. To go global, she had a fixed cost of $10,000 and a variable cost of $2 per biscuit. We want to express the cost C of producing Q biscuits. All right, this is a bit of a softball question. Who can answer it for me? Yasmin. That's exactly right. 10,000 plus 2Q. Okay. Using parts A and D, we want to express the total cost of Anna Marie's operation in terms of P. Okay? So right now we have cost in terms of Q and Q in terms of P. So we can just go ahead and plug in again. C of P is going to be equal to 10,000 plus 2 times, and in these parentheses, I'm going to put the expression which we computed, which gave Q in terms of P. So that's up in A. Let's see what it was again. We had Q of P is negative 5,544 P plus 37,820. I'm just going to plug that right in. P plus 37,820. Okay, and if I multiply that all out, then I'll get a nice, neat formula. Okay, using parts B and E, I'll do this really quickly and then we'll be done. Express the total profit made pi in terms of the price P of each biscuit. Well, we know that pi of P, which remember is just a letter, is going to be equal to my revenue based on price minus my cost based on price, which equals, what was it, B? Let's go back to B. Negative 5,544 P squared plus 37,820 P. And I'm going to subtract the cost function, which is 10,000 plus 2 times this stuff, 120. And I could simplify that further, but it makes no sense to do that in class right now because that would be a waste of our time. Okay, that's all we have for today. Next time, I'll see you guys on Wednesday. Stick around after class if you still have questions about anything or if you want to see some additional examples.
Schedules for Labor Day weekend?
We have an E-Day on Labor Day.
So there is.
So we won't have in-person class on Labor Day, but there will be a video that you need to watch.
Cool. Thank you.
Yep. Okay, some people sticking around want to see some extra stuff?
Yeah,
Okay, do you have anything in mind, or should I just keep going on this one?
I don't know anything in mind.
Yes, Renee?
I wanted to ask about price elastic and price inelastic. Do
Mhm.
you have to know that?
Oh yeah, good question. Let me check our book. This might be the only chapter that we're doing. Well, it won't. We'll definitely have marginal cost, and marginal profit. Let me look at the. Elasticity of demand. It is in here. It's in chapter 4, so we probably won't get to it for quite a while. It'd probably be late October.
Okay, thank you. And I have one more question.
Mm-hmm.
So will you have us, like in future homework problems or on a test, will you have us draw the supply curve and then show when it changes? I think, because I'm thinking back to government econ when we had to do stuff like this. So will we have to do that for graphs at all in the future?
I'm not thrilled about the way that the graphs are presented in the book, which makes me feel like I'd rather not do something like that. However, there's no guarantees. No, everything that gets covered in the book is subject material that could show up on the exam. That's what I'll say in order to be as vague as possible.
Okay, thank you. Have a good afternoon.
Yep, you too. Okay, shall we try G? Okay, we'll try G. Oh no, we're not going to do G. That's a graphing calculator problem. Maybe, okay, you guys want to see supply and demand stuff, or do you guys want to see the stuff we did earlier? Because we skipped problem 3. So do you want to work on computing C of Q, R of Q, and pi of Q? Okay, we'll do problem number 3. To start up her online business selling paintings, Shelley has to pay a $12 fee for her domain. Each piece that she makes will be sold for $75, and her supplies for the piece will cost $35. Okay, write formulas for C of Q, R of Q, and pi of Q. Who wants to try C of Q? Yeah.
The $12 plus 35 Q.
$12 plus 35Q. Exactly right. My fixed cost is $12. That's what I have to pay to get my website up and running. And my variable cost is $35. In other words, to make each painting, I have to pay $35 for the canvas and the paints that are going to go on it. Okay, R of Q, our revenue, remember, represents the amount of money which comes in overall. Mary, you want to try that one? Exactly right, 75Q. Okay, and pi of Q, how do I get that one?
Revenue minus your cost.
Yep, exactly right. Revenue minus cost equals 75Q minus 12 plus 35Q. If I subtract 35 from 75, I get 40Q minus 12. Okay, feel good about that? Yeah, I think these are the easier ones. All right, what's the marginal cost? Ryan.
35.
Exactly, $35 per painting. Marginal profit. $40 per painting. Okay. Marginal revenue would be $75 per painting. Okay. Does anyone have questions about that problem? That one felt pretty straightforward.
Can you explain marginal costs and marginal profit a little more?
Yeah, sure. So marginal cost and marginal profit represent the rate at which I'm bringing money in. Okay? So for example, if I have some graph here of, let's do profit. Profit and quantity. And typically it's gonna look like a line, but maybe it could be curvy. Later on, it'll be curvy. And what does this mean? This means that I am making, that as I increase the quantity of goods that I am producing, the amount of profit that I'm making is increasing, right? It's going up, 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 right? If my curve looked something more like, let me draw it a little bit weirder. It might look something like this, right? Then what this says is the more I make, the more profit I have. But maybe it's really expensive to produce this item. So as I make more and more and more and more, my venture becomes less and less profitable. And if I make too many items, then my profit goes back down to zero, right? So the marginal profit represents the rate at which my, the marginal profit represents the rate at which my profit is increasing or decreasing based on the number of goods that I sell. So in this particular graph, I want to produce the amount Q1 that maximizes my profit. Okay, so that's an example of that. So in our case, marginal profit is representing the slope of the profit line. Okay, I make $0 if I make 0 things, and as I increase the goods, I make more profit. Okay, it's not always going to be like that, but for our case right now, it is. Yeah, it's a little bit confusing. Marginal cost and marginal profit. It's tricky to give a great physical interpretation of those values. All right, let's go down. We can try problem number 5. Okay. Supply curve for a given product is Q equals 600p, and the demand curve is Q equals 33,000 minus 500p for 0 less than p less than or equal to 60. At a price of $10, what quantity are consumers willing to buy? Let's just start with that first part of the question. At a price of $10, what are consumers willing to buy? Which formula should I use? Q equals 600p or Q equals 33k minus 500p, right?
The demand curve.
I should use the demand curve, yes. Consumers wanting to buy something corresponds to the demand curve. So I'm going to do 33,000 minus 500 times 10. So 33,000 minus 5,000, I get willing to buy 28,000 units. And I'm going to use the other formula to figure out what quantity are producers willing to supply. Okay, that's the amount that I want to make. So it's going to be 600 times 10. So producers willing to make 6,000 units. Okay, so in this case we have an imbalance, right? We can read this as saying the price is really good, right? Which means that people really want to buy a lot of units. However, since the price is good, the venture is not that profitable for suppliers, which is why they're only willing to produce 6,000 units, because it's not a great deal for the people who are selling, okay? So this is a case where the demand is outweighing the supply. Okay. What is the equilibrium price? Well, equilibrium means supply equals demand, just like how you would expect. So 33,000 minus 500p equals 600p. Solve this, we get 33,000 equals 1100p, implies that p equals 30. Okay. Yes?
I don't really understand, why are the producers only going to make like 6,000? Can you explain that like in?
Sure. So we're given these two formulas. We have Q equals 600p and Q equals 33,000 minus 500p. So the green one, Q equals 600p, is the supply curve. So that's the curve which dictates how many units producers want to make depending on the price. If the price is higher, then I want to make more so I can make more money. So the reason that the suppliers are only willing to make 6,000 units is at a price of $10, I might not be making much money.
Okay, so they put like the resources into like something else that would be more profit.
Exactly, I would put my resources elsewhere. So it's not inherently clear what the situation is just from looking at the algebra here. What we can say for sure is that people want to buy more stuff than people are willing to produce. As for why, we have to infer that it's maybe not so profitable, maybe it's difficult to produce, maybe it's annoying to, license your factory and that sort of thing. There are any number of factors could go in to the to why the supply curve is defined this way. But we're just given the fact that it is defined this way, and don't worry about why. Just tell us how many the suppliers want to make. Okay, how about the equilibrium quantity? Does that make sense? How I solved for this P here? Okay, so equilibrium price means I want to find the price such that the amount that people want to buy is equal to the amount that people want to produce. That's kind of like our Goldilocks situation. That's where everybody who's wanting to have something can get it. And the people who are wanting to sell that thing, they can sell all of their product. Okay, so that's why I set the supply function equal to the demand function. So I set these red and green guys equal to each other, and then I solved for P using algebra. Okay. How about the equilibrium quantity? How can I find that? Any ideas? I already found the equilibrium price. It's $30.
I'm trying to figure out like how, like to get the quantity equal to what?
So equilibrium price is $30. If I know what the price is, what should the quantity be? Is there a way I can figure that out? How can I do it?
Plug it in the Q equals 600 feet.
Yeah, exactly. I can plug it into either the green equation or the red one. Either. They're going to give me the same number. Okay, that's because it's the equilibrium point. So 600 times 30 is going to be equal to 18,000. Okay, so in an ideal world, the producers produce 18,000, the demanders demand 18,000, and everybody walks away happy. Okay. Questions about these three problems here? Okay. I think we'll call it today. I have office hours at noon online. So if you want to talk some more, I'll have the link on Blackboard for you guys to come to the office hours. Or maybe I'll send an email or something.
Yeah,
Yep.